is the option that we've added for iMachining default machine and material. If you all remember, whenever you started a new project, you would always get the iMachining field as shown over here. This area over here will always be empty, and you'd always have to fill it with the necessary machine database and the material, and even though you've already picked your machine. So now we've added inside our VMID, which I'll show you very shortly, the option for automatically filling the iMachining data and the material data. Let's see exactly how this works. I'm going to start by creating a new operation. If I go into New Milling, and I'll just click on OK, you'll note that immediately when I started my program and I go into the CAM part, you'll see that I already have a default iMachining data as far as the machining database, the machine database, as well as the material database. Where does all this come from? We'll show you that in a moment. But you can see all this comes here as default. You can always change it to something else, but the defaults are already set, as well as the material. So let's continue now. I'll just now create a regular home position. I'll click it on the top over there, center of the box. I'll click on OK. We'll accept that. My stock and target are already done. And I'm going to click on OK. Now let's take a look where all the information came from. As far as the material that we have in there, as shown over here, that came from this particular place. If I were to go into my CAM settings and to iMachining, we have a field here for default material database. So if your particular workshop in most cases works with a specific material, say aluminum, okay? So you can have your iMachining always load with this particular material. You can change it, and if you don't want to load it with any material, you can always go to the top and choose the blank. That way it'll work exactly the way it did before, where you always have to choose the material. So that's where it got its material from. Now let's take a look where it takes the information as to which machine database to use. If I were to go into my SolidCAM tree manager and we go into our machine, our VMID, I'll open it up and let's go over to working style. Now in working style, we've added a new folder here called iMachining. I'll click on iMachining and you'll note the following. We have here default machine database. And the default machine database is filled. This actually looks at the list of the databases that you have, and you can put any machine that you want in here. So therefore, when I loaded this particular controller, it automatically came in with this particular machine database. Now, you'll note one more thing. We also have here a default material database, and I have it blank. So the question may come up as to why do I need this if I already have a material database in my settings? The answer is very simple. There are machine shops that'll say, okay, you know what? I have all different types of material, but this particular machine that I'm working on, this particular machine will always work with one material. No matter what I have in general, this machine will always work in a specific material. Say, for example, that machine always works in a stainless steel material. So what I'll do is, instead of leaving a blank, I'll go and fill it for this particular machine with a stainless steel. Of course, I'll save that and exit. Okay, so now let's take a look what happens if I start a new project. Okay, again, I'll load a part and we'll do the process again. We'll go to New, Milling. We'll click on OK. And note, even though my SolidCAM settings in our machining was for aluminum, this particular machine works with stainless steel. And this time it comes up with the stainless steel material. Okay, why? Because this machine works with stainless steel. That doesn't mean I can't change it. I can always come here and make any changes. Everything is still open. You can make any changes you want. Okay, so now I'm going to just click on OK, and we're all set. But I just wanted to also mention one more thing before I go to my next part of the webinar. Notice what I had to do in order to create my CAM project. Okay, I had to open up this window. I have to go define my home position. Click on OK. Click on OK again. Accept this. Make sure my stock and target are defined. In this particular case, they're defined automatically. And then click on OK to get to this stage. Which brings me to the next part of the webinar itself. Quick Start Settings. In SolidCAM, this is something we added already in the beginning of Service Pack 3. We've added the option for creating quick starts. In other words, to get you from the time you click on milling directly to your operations without having to do all those clicks that I just showed you that I had to do. What do we have to do in the settings itself? Well, let's exactly take a look now at the program. Let's go into our SolidCAM settings, and we'll go into CAM part. Now, the first thing we'll show you in CAM part is this field over here, Auto Select Project Location. What does that mean? If I were to start a new project, sorry, my mistake. Okay, if I were to start a new project, you always get this window. I want to skip this window. I don't want to see it anymore. Okay, so if I were to go into my SolidCAM settings, CAM part, auto select project location, I want to skip that window. That's what this does. Okay, but like I said, I also want to say, you know what? I'm a place that I'm only going to create one home position. Okay, I'm always going to use a specific machine. I just want to get started. Or I'm a new user. I just want to get to start the feel of the program itself. So for that, we have an automatic part definition. And what I'm going to do over here is say, okay, you know what? Let's use the default CNC controller so I won't stop and make sure I picked one already. It's going to use what I chose as my default controller. I'm going to create my home position automatically at the top center of my stock model box, and don't show me the coordinate system manager after I've created that first home position. I'll click on OK. Now let's see how quickly the person has what the person has to do in order to start his to actually start working. We'll go to New, Milling, and just sit back. We are now ready to start working. Okay? So now it's done in a few seconds. rather than having to do all those steps that I showed you in the beginning. Okay, now let's get back to the actual PowerPoint itself. We'll go to our next step. Something that we've wanted to do for a long time, and that is to make creating an operation a lot quicker with a lot less clicks. So what we've done is we've added new ribbons into SolidWorks for each group. For example, for our 2.5D milling, we've added everything that you would do in a 2.5D milling for 2.5D milling operations. AFRM, a separate tab for AFRM. Separate tab for SolidCAM 3D, where everything is right in front of you. In a few moments, we'll see exactly how this works. Multi-axis, turning, templates, all of these we've added separate ribbons inside SolidWorks. Now let's take a look at how this works. Now, as you can see here, we have all our different tabs. And these are SolidWorks tabs with all the different operations. Now, previously, if I wanted to add a 2.5D milling operation, what would I do in many cases? I would have to right-click, and all the old-timers still do this. Right-click, that's one click. Add milling operation, that's two. Oh, and look here, start looking here for my profile. Ah, there it is, my profile operation. Going through this list to find everything that I need. Then I pick the profile operation and start doing my operations. Want to do a face mill operation? I have to go right-click again, add milling operation, face mill, or iMachining. Everything I'd have to do that extra steps over here. Right-click, add milling operation. What we have now is everything here is out front. I'm doing my SolidCAM 2.5D operations. I have direct icons to them. AFRM operations, direct to them. SolidCAM 3D, they're always open. Okay, if I want one ribbon that has all of these, well, we have the SolidCAM operations ribbon, where we have all of them as well. Okay, now note, in every single one of these ribbons that we have over here, we have new, open, calculate all, generate, simulate, tool sheet. These are things that are done no matter what stage you're in. So if I've done SolidCAM 3D operations and I want to go now generate G-code for all of them, I don't have to go back to part and then go generate all. Everything is right here. In every single one of these ribbons, this area is always available. The only thing that changed in the ribbons is just this area over here. Now let's actually start working with it and see what happens, which is going to bring me to my next point also. So before I actually continue, let me just show you what my next point is. One of the things we've also added is showing the Toolpath preview immediately after calculate. So now when you click on calculate, the moment it finishes calculating, you'll see your Toolpath over here, as well as it being checked off inside our CAM tree. Now there are settings for that as well. So if you don't want to see them, you don't have to. And we'll show that to you in a few moments. So let's get back now to our actual part. Let's first start, in this particular case, with our SolidCAM 2.5D. We're going to start with a face mill operation. Okay? So I'm going to go to click on face mill, on face. You'll note in this particular case, I personally am working with a template, with a specific tool already. Okay? With a specific technology, which you'll see in a moment. So all I have to do here is click to choose my geometry, which will be the actual target itself. You'll see my tool is already defined because I have that inside my template. My levels, I'm just going to leave it at 0. And my technology, I like to work with a spiral technology. Okay, so I'm all set. Now note, the moment I click on Save and Calculate, let's actually move the part over to the side, you'll see even better. The moment I click on Save and Calculate, okay, it didn't work. Why didn't it work? Remember I said I had my settings? Let's go back to my SolidCAM part settings. Let me show you exactly where that's located. If I go to my Toolpath simulation, we have simulation modes. And in our simulation modes, we have Toolpath, preview of Toolpath after calculation for all. So let's turn them all on. Okay? And I'll save that. Okay? Now, let me go calculate. And you see our Toolpath is showing now automatically. Okay? Let's do a different operation. Now, previously, like I said, we have our tabs now, but beforehand, I will just remind you what you had to do. If I want to do, let's say, a profile operation, what I would have to do is I would have to right-click, add milling operation, profile. So 1, 2, 3. Instead of 1 directly on the tab over here. Okay? So again, we're taking a look at how quickly and how simple it is to actually get into our operations directly from the ribbons. So let's continue now and create another operation over here of profile. We'll click on geometry. I'm going to use the option of curve propagation and click on this edge over here, and it chooses that geometry in one click. We'll create a tool. In this particular case, I'm going to create use an end mill that has a 10 millimeter diameter. We're going to have it 20 millimeters cutting length. We'll give it 3 flutes, and we'll select that. Okay, our levels, we have our upper level over here, our profile depth up until there, and in our technology, we're just going to use a rough cut first, and then we have our finish. And in my links, I'm going to use the default setting of arc. Now, people have asked me, why do we have a default setting of arc instead of none? Because if you have here none, no matter what, almost always, none will always crash into stock material. This is much safer. In any case, everyone will always come in here and make changes, but leaving it at none would always be problematic. Okay, let me do calculate. And you can see your toolpath here already. Okay, exit. Now, if I don't want to see the toolpath anymore, just unclick it. Okay, now I want to do the inside area over here. But you know what? Doing the inside area over here, I can't think of a better way to do it, than using iMachining 3D. So I can go into iMachining 3D again by right-clicking, add milling operation, 3D iMachining, or we've also added it to our SolidCAM 2.5D at the end. Why did we add it over here? Because this can be used on prismatic parts, which is usually considered a 2.5D part. So we've added it here as well because you're using iMachining 3D for prismatic parts. I'll click on iMachining 3D, go directly into the operation. I'm going to choose the option of 3D prismatic. I'm going to choose a tool that I had before. Okay? Our levels automatic, but you know what? I know since I already did finish the outside, I'm just going to go down to that level. So I don't want to have it calculating all the way down. So I'm just going to click onto that level over there. Of course, we have our technology wizard doing all the correct calculations for our feeds and spin rates, and as well as our down steps. And in our technology, we have our offsets as well. Okay, now let me do save and calculate. And when it finishes doing the calculation, you'll see this in a moment. You can see the toolpath here as well. Okay, we can continue on. Let's actually do two more operations. We have here this counter bore hole as well as this tapped hole. So let's go and use our hole wizard process. Again, I can go into right click, add milling operation. We can go into, let's start looking for the process. Oh, no, it's in a different place. I have to go here and go to add hole wizard process. It's right in front of you. Add hole wizard process. Choosing the counter bore hole, we'll click on the wall of the counter bore, and all the operations are created, as well as you can see the toolpath preview as well. Continuing on for the tapped holes, for the tapped holes itself, we'll click on the actual tapped hole, and we'll have our operations. Again, you can see the preview of these as well. So working with the tabs makes getting into your operations a lot quicker, eliminating a lot of the clicks that you have to do. No more right clicking over here, adding milling operations. Everything is in front of you here. By the way, if I stand on one of these, okay, and I just turn the wheel on my mouse, it changes tabs. I don't even have to click. Just by turning the wheel on my mouse, I can go from one tab to another and choose what I want. Okay, now let's continue with the next part of the webinar. Let's talk about the issue of creating coordinate systems, new coordinate systems, by using the matrix option, but a transform option of creating a new coordinate system, as well as rotating it around a specific axis. Okay? So what I'm going to do is I'm going to load a different part. Let's start, first of all, with this particular part over here. What we actually see in our screen, you'll see this in a moment, is the following. I have here two parts. Actually, it's just one part, repeated another time. Okay? Now, I've programmed everything on this part itself. Now, in this particular case, I have a regular 3-axis machine. Okay? Nothing special. And what I did was very simple, which is done very typically in many machine shops. They'll put down one vise, and then they'll put another vise on the table to hold another part, so they can do two separate parts. But note, these parts, the devices, and I did it on purpose this way so you can see that this is what can happen. They're not aligned with each other, okay? You have one distance from here from this point to this point, as well as in the X direction and in the Y direction. They're not aligned with each other. So how did you used to have to create a copied operation onto this particular part over here? Well, one way of doing it was, let's just take this face mill operation that I've done here on this operation over here. Okay? If I were to right click on transform, what I would have to do is go to translate, list. I would have to know the measurement between the first one and the second one. Okay, I'll include the original operation. I already measured it, and I happen to know it's 350 in the X direction and 50 in the Y direction with no change in my 0 direction, and put that in. Okay? So now, as you can see, it's on both. Okay, that's really nice. However, next time I come back to my machine, what would happen? My vices may not necessarily be the exact same distance away. I'm not going to start going and placing it exactly the way it is. So what I would have to do is, again, I'd have to measure the distance, go back into my transform for all of the operations, because I'll be doing it on all of these operations, and then I'd have to go back in here, go back to the transform, open it up, delete this, okay, and then make changes. That's a hard way to work. What we've done is very simple. First of all, let me get rid of what I did. Okay, so I'll go to transform and I'll say clear all. Fine. What we've done is as follows. First of all, we've added an option for creating according to, if I go back to transform, coordinate systems. But before that, I have to make sure I have another coordinate system on this part. So let's go into my coordinate system manager. And right now, all I have is one coordinate system. Okay? So I have to create another one. Well, there are two ways I can create it. In this particular case, it's only one other part, so it's no big deal. So I can go add, and I can go, okay, let's click on the top, when I have a top center of the model box, just like the other one is, sorry. I'm just going to click over here. And I'll get a second operation. Whoops, made a mistake. Let's do this again. I want to have this as another MAC number, so I'll change this to 2. And we'll click over here. We have another coordinate system. Clicked over there to get back to there. Okay, this is fine, no problem. And we have our second coordinate system. Another way to create another coordinate system, in this particular case, I can do that. Let's first of all take what I have over here and delete it. Okay. Now let's do the following. I'm going to right click on my first position, and we have here the option of create transformed copies. Okay? Let's first go to translate. And in this particular case, I'm just going to go to list. Now, the very first time I do this, just so that I can see this correctly, I need to know what the distance is. So I did it. I'm going to put it in the values of 350, 50, and 0, enter. Click OK and create. Now what do I have? I have another home position here. Okay. Now, let's start actually implementing this into our operations itself. If we take a look at our operations, our first operation is a face mill operation. Okay. And our second operation is a profile operation. Our third and fourth operation, as you can see, it's a a toolbox operation, which I did in one corner, but I also did a revolve around the center over here. So we already have a transform in this particular part. Same thing with this particular operation. We also have a transform in this operation here as well. Then we have some pocket operations going through the pocket part itself. Okay, as well over here. And we also have this particular pocket operation, which was done in one corner. And I also rotated that around this particular center. And at the very end, I have my chamfer recognition operation. Okay, so what I'm going to do is the following. First, I'm going to take the operations that I do not have a transform on them yet. So that would be these two operations as well as these operations over here. I'm going to right click, go to transform, and now choose coordinate system. I'm going to include, okay, I want it on the first one as well as Mac 2. And as you can see, the moment I clicked on that, you can see that coordinate system popping up. Click on OK, and it's done. Okay, next I want to do the same for these operations as well. So I'll do that as well. Transform. You can see that these operations already have a rotate transform on them. So I'm just going to add to that, on top of that rotate, again, the coordinate system exactly the way I did it last time. Click on OK, and we're all set. Now, if I click on to show all of my tool passes, you can see that they were done on, now we have it on all of the, and every single one of operation, and both parts are machined. The beauty of this is very simple. Next time the person comes back and has to do this operation, these operations again, say a month from now he comes back, he doesn't make a difference where he puts the vices on the machine. All he has to do on the machine is create his first home position, create his second home position, and that's it. He doesn't have to go back and measure, okay, what's the distance between the two, because it's going according to the coordinate system. Okay, this is a typical case of vices. Now, let's take a look at a different case, one that's a little more complicated. Okay, we're going to load this part here. We have this part sitting on a tombstone on all sides. In other words, we have a total of 8 parts, and we have our transform of our Mac positions are in 2 different areas. One, we have to transform it from here to here, as well as transform it around the 4th axis, which we see. I've created a line over here. If I put it over here, you can see there's an actual line over here in the middle. That's my 4th axis, just to show exactly what I'm talking about. Now, the operations is exactly like I had in my previous part. So now let's go into our coordinate system manager. And as you can see at this moment, all I have is one home position, one coordinate system. So I'm going to right click and go directly to create transform copies. Now, the first thing I'm going to do is I'm first going to do the translate from here to here. So I'll go to translate matrix. My X direction, it only has one. My Y direction, I have 2. And what's the different distance in my Y direction? 400 millimeters. Okay, so I put that information in. Now, in addition to that, I want to take what I've done here, these 2 coordinate systems, and rotate them around my 4th axis, creating more. So I'll go Now I'll take this, continue on, fourth axis, and I'll do the following. I want to turn it 90 degrees, a total of 3 times, because my first time I already have, so I need 3 more, and insert them. Now, in addition, I want to tell it around what to turn it. Now, I can do that in 2 ways, either by choosing a vector, where I pick a particular line and then pick the start of this line here, okay, and the end of that line. Or I can say the following. I can say, let's use a specific axis. In this particular case, we're turning around our y-axis. So I'll choose my y-axis. And here I'm going to pick my pivot point. Click. Just click on that point, the edge of that line. Click on OK. Now let's create them. What I've done here now is I've created 7 more home positions, a total of 8 positions in all. Okay, now let's put that to good use. So I'm going to do exactly what I did last time. Let's first take this group over here. Okay, right click, transform, and we'll go to coordinate system. Now you can see the entire list of my coordinate system over here. So I'm going to say include original, and instead of checking all of them, I'm just going to click on check all. Okay? Now, what it's going to do, it's going to go by first to second to the third to the fourth. You know what? I'd like to even make a little change in the order that I have over here. I want to have it go to the first, to the second, but then to the fourth and to the third. No problem. Click on Mac 4, and I can move it up. Now, 5 and 6, I want to leave it the same way it is, but 7 and 8, I want to change. So I can click on Mac 8 and move it up, or Mac 7 and move that down. Either way. Click on OK. And that's done. Same thing with the rest of these over here. The second group, right-click, transform, coordinate system, include original, check all, make any changes I want over here, click on OK, and we're all set. Just click on the operations. You can see all of our operations on all of our parts. Okay. Now, actually, let me even run the simulation. Simulate. Let's do the machine simulation. This particular case, this particular machine is a vertical machine. Sorry, a horizontal machine. And we'll see that in a moment. You can see that over here. And as you can see, as I start the simulation itself, it'll go up, down, and then continue on with working with the rest of the operations on the part itself. So you saw how quickly and easily it was using the option of creating new coordinate systems, and how easily it is just to transform via the option of coordinate systems. Okay, that's basically it. So just to review what we've gone through, we've seen the new tabs that we have in SolidCAM for our operations. We've seen the automatic fill, how we automatically put in the information for the iMachining data as far as the machine data and the material data. We've seen the option of automatically showing the toolpath when you finish the calculation. And we've also taken a look at, we saw in the settings how you can turn them on and off. And of course, we reviewed the issue of creating a transform via via coordinate systems. Okay, so if there are any questions, I'll go through the questions now.